This video is about the section called Standard Deviation. So when you're working with statistics, you're often working with a large quantity of data. So they're going to give you a very, very long list of numbers. And usually these numbers will not be in order. So in this section, it actually doesn't start out talking about standard deviation. First, it talks about range and interquartile range. So here is my set of data. When we're going to find the range or the interquartile range, we need to have this data in order. So if I'm rearranging this and putting it in order, I'm going to start crossing out numbers that I've put on my new list. So for example, I know 16 is the smallest out of all of these. I'm going to cross that off to make sure I know I've used it. Next is 17. Next we have two 18s. There are also two 19s, three 21s, three 22s as well, (24, 25, 28, and then 29 and 30. So there's all my data in order. The range itself is fairly easy. Range is just the highest minus the lowest. So the highest number in this data is 30. The lowest is 16. 30 minus 16 is 14. So that is our range of our data. The interquartile range is a little bit more difficult to calculate. In order to find the interquartile range, first we have to calculate the quarters. So we're going to find the median of this data, the middle number of our data. So for me, the easiest way to find the middle is to cross off the first, then the last, and then I move on to the next one, the second and the second to last, the third and the third to last, fourth to last. I keep going until there are either, sometimes there's two numbers left, sometimes just one number left. In this case, there is only one number left, and that is called the median. This splits this data in half, and this is considered quarter 2. To find quarter 3 and quarter 1, we're going to have to find the medians of all the data to the right of the median and to the left of the median. So we're going to have to do this process again. So I'm going to go through and get rid of all the lines, just so they're not confusing us. And we're going to find the medians of just the right-hand side and just the left-hand side. So we're going to have to do this again. Again, I'm going to cross off the first and the last, second to last, third to last. Now this time, I can't cross off anymore because both my numbers would be gone. So I need to find the average of these two numbers, or what's exactly halfway between them. So halfway between 24 and 25 is 24.5. That is considered quarter 3. Now we do this process with the first part of the data. 16 is first, 21 is last, 17 is second to last, 21 is second to last. 18 and 19 cross off, and then we have 2 left again. We want exactly halfway between, so 18.5, and that is quarter 1. So the interquartile range is quarter 3 minus quarter 1. That means quarter 3 minus quarter 1 is 24.5 minus 18.5, which equals 6. So that's how we calculate the range and the interquartile range. Then the section will move on to talking about standard deviation. So when you're finding the standard deviation of data, there are going to be some new symbols used. First, there is x with a line over it. In statistics, that represents the mean, and mean is the fancy math way of saying the average. There's going to be this symbol. It is the lowercase Greek letter sigma, and it stands for standard deviation. Next, there is the capital letter sigma, also Greek, and it stands for summation. It means to add a whole bunch of stuff together. So the process of finding your standard deviation is a very long process. And it starts by first finding the mean. So step 1, we find the mean. The second step, you're going to take every number from your data set and you're going to subtract the mean from it. You're going to find the difference. So you're going to subtract the mean from every number. They're going to represent this, because mean is represented by x with the line over it. They're going to represent this as x minus x with the line over it. Then you are going to square all those numbers. So we've done x minus x. Now we're going to square the x minus the mean of x. Fourth, you're going to find the average of all the numbers you found in step 3. So when you find the average, you add a whole bunch of things together, and then you divide by how many there are. So mathematically, they're going to represent that using the summation symbol, telling us add a whole bunch of things together. We're adding specifically all the things from step 3, and then we're dividing by n, where n is how many items are in your data set. And then 5, you're going to square root that answer. So for most of this, you're going to have a lot of numbers to work with. Step 5, you only have one number left to work with. So you're going to square root. Again, mathematically, they're going to represent that using this whole math symbol set up with our sigma and our mean. So the standard deviation is that formula. So let's go through a set of data and find all of this information. So let's say we have 13, 15, 17, 20, 10, 21, and 10. Now it's still usually a good idea to put it in order. So we have 10, 10, 13, 15, 17, 20, and 21. So now we have our data in order. We need to find the mean. We are on step 1 right now. So to find the mean, I'm going to add all of these up. Which is 106. And I'm going to divide them by however many there are. So just counting, we have 1, 2, 3, 4, 5, 6, 7 numbers we're working with. So divided by 7 is 15.1, approximately. So next, we have to go through and find all of the differences. In other words, we're doing a lot of subtraction. So our first number was 10. 10 minus the mean of 15.1 is negative 5.1. We do that again because the next number is also 10. 10 minus 15.1 is negative 5.1. We do it again with the 13. 13 minus 15.1 is negative 2.1. So you can't see the list of data anymore, but I do have it written down, so I'll just keep going off my list. The next number was 15. 15 minus 15.1 is negative 0.1. Next was 17. Gives us 1.9. Next was 20, which gives us 4.9. Next is 21, gives us 5.9. So that is all of our x minus the mean, I should say. So next we had to square all of those, x minus the mean squared. So I have to do negative 5.1 squared. Negative 5.1 squared means multiply negative 5.1 times negative 5.1, so this will come out positive 26.01. We're going to square the next one. That will come out the same because they matched. Negative 2.1 squared is 4.41. Negative 0.1 squared is 0.01. I was looking at the answer instead of what I was squaring. 1.9 squared is 3.61. 4.9 squared is 24.01. And 5.9 squared is 34.81. So now the fourth step is to find the average of all these squared pieces. So we're adding them all together and dividing by the number of numbers. So if I add the 26.01 plus 26.01 plus 4.41 plus going down all the way to the bottom, all of them added together is 118.87. And then we are dividing by the number of numbers. There are 1, 2, 3, 4, 5, 6, 7. So we have divided by 7. That gives us a number of 16.98. Again, that's approximately. There were more decimal places, but we're trying to keep it simple as possible. So then the last step to find the standard deviation was to square root that final number that you get. So we did all of this and got 16.98. We still need to square root that, which gives us 4.1. So the standard deviation for this data set is 4.1. So let's talk about a little more what this standard deviation means. If we were to graph this data just with a little chart that shows all our numbers represented on a number line. So our data set from before was 10, 10, 13, 15, 17, 20, 21. So I'm going to put an X above my 10 to show I had one value that was 10, a second X to show I had a second value that was 10, 13 is in between the 12 and the 14, so when I put it above, it'll be in the middle of those. 15 is also in between, and 17 is also in between. 20, we have a 20 marked, so we can put it directly above, and 21 will be halfway in between. So looking at this data, first we're going to mark the mean. The mean we found, the very first mean with our original data set, was 15.1. That's a little bit above 15. This was our mean. The standard deviation is 4.1. That means if we go up by 4.1 or down by 4.1, so if we add 4.1 to 15.1, we get 19.2. This is called one standard deviation. It's one standard deviation away from the mean. So at 19.2, we're one standard deviation away. In the other direction, if I do 15.1 minus 4.1, that will take us to 11. That is also considered one standard deviation away. I've only done one 4.1 away from the middle. If I do it again, because I still have some data outside my standard deviations here. If I do it again, I add 4.1 one more time. We take it up to 23.3. So that would be two standard deviations away. In the other direction, if I minus 4.1 from 11, that takes us to 6.9. That's two standard deviations away. So now I can say that all of my data is within two standard deviations. My line here for my second standard deviation encloses all the data I have, and the same thing with the line on the left. That encloses all the data. All of it is between those standard deviations. So all my data is within two standard deviations of the average, of the mean. They can also be assigned something called a z-score. So our z-score is related to how far these standard deviations are away. So when you're one standard deviation away exactly, this is considered a z-score of 1. So two standard deviations would be a z-score of 2. Now, when we're looking at the other standard deviations, when we looked at it as a standard deviation, we didn't care if it was negative or positive. Z-score is going to care. The 11 is one standard deviation away, but it's going to have a z-score of -1 because we went to the left one of the mean. Two standard deviations away would be a z-score of -2. Now the numbers in between don't necessarily have an exact z-score. They're not 1 away or 2 away or -1 or -2 away. So we need a formula to find, like say that 13. We want to know 13's z-score. The formula for the z-score of any value is the value minus the mean divided by the standard deviation. So for the data we were working with, I said let's look at 13 it had a mean of 15.1 and a standard deviation of 4.1. So for 13 minus 15.1, because 13 was the value, 15.1 was the mean, the standard deviation was 4.1. That would end up equaling, so that would equal negative 2.1 divided by 4.1, or negative 0.512. They'd probably want you to round to the tenths place, so just negative 0.5. So that has a z-score of only negative 0.5. So your z-scores don't necessarily have to be whole numbers. So that is all the topics they cover in the standard deviation section. We found the range by doing highest minus lowest. We found interquartile range by doing quarter 3 minus quarter 1. We found standard deviation by finding the mean, then subtracting the mean from every value in our data set, squaring that number, finding the average of all those squared differences, and square rooting that to tell us how far away the different types of data are. What is our standard deviation from the mean, from the center of our data? And then finally, we also found our z-scores using value minus mean divided by standard deviation. So that concludes our discussion.